You're listening to LeadAI.dev, your daily updates on AI development. Today's topic is Gemini 3.1 Flash TTS delivers granular audio control for AI speech. Here's a quick overview. Google DeepMind's Gemini 3.1 Flash TTS introduces granular audio tags that give developers precise control over AI speech generation with expressive capabilities. Now, let's ask our analyst about these developments. What's new? Gemini 3.1 Flash TTS introduces granular audio control.
Google DeepMind has launched Gemini 3.1 Flash TTS, a next-generation text-to-speech model that revolutionizes AI speech generation through granular audio tags. This latest iteration builds on the Gemini Flash architecture to deliver unprecedented control over voice characteristics, emotional expression, and speech patterns. The model introduces a comprehensive tagging system that allows developers to specify precise audio attributes, including tone, pace, emphasis, and emotional nuance within individual text segments. The granular audio tag system operates through structured markup that can be embedded directly within text input. Developers can specify attributes like speaking rate variations, pitch modulation, emotional intensity levels, and contextual emphasis markers. The model supports real-time processing with low latency, making it suitable for interactive applications including conversational AI, virtual assistants, and dynamic content generation. The tagging system includes over 50 distinct audio parameters that can be combined and layered for complex speech patterns. This release represents a significant advancement over previous text-to-speech models that typically offered only basic voice selection and speed controls. Traditional TTS systems required separate API calls or pre-processing steps to achieve varied expression, while Gemini 3.1 Flash TTS processes complex audio instructions within a single inference pass. The model maintains consistent voice quality across different emotional states and speaking styles, addressing a common limitation where expressive TTS models would exhibit voice drift or quality degradation when switching between different speech characteristics. Granular audio tags support over 50 distinct parameters, including pitch, pace, emphasis, and emotional intensity real-time processing with sub-200 milliseconds latency for interactive applications and conversational AI systems. Single inference pass handles complex multi-attribute speech generation without quality degradation. Structured markup system integrates directly with existing text processing workflows. Consistent voice quality maintained across emotional states and speaking style variations.
Thank you for that analysis. Let's move on. Who benefits from Gemini 3.1 Flash TTS audio control features?
Content creators and media production teams gain the most immediate value from Gemini 3.1 Flash TTS's granular control capabilities. Podcast producers, audiobook creators, and video content developers can now generate expressive narration with precise emotional timing without requiring voice actor recordings. Marketing teams creating audio advertisements benefit from the ability to match brand voice guidelines while incorporating specific emphasis patterns and emotional cues that align with campaign objectives. Educational content developers can create engaging instructional materials with varied speaking patterns that maintain student attention. Enterprise developers building conversational AI systems and customer service applications represent another primary beneficiary group. The granular audio tags enable chatbots and virtual assistants to deliver contextually appropriate responses with emotional intelligence. Call center automation systems can now provide empathetic customer interactions while maintaining consistent service quality. Healthcare applications benefit from the ability to generate compassionate, clearly articulated patient communications with appropriate emotional sensitivity for different medical contexts. Individual developers and small teams working on accessibility applications should approach this tool with realistic expectations about integration complexity. While the granular control offers powerful capabilities, implementing sophisticated audio tag systems requires significant development time and audio engineering knowledge. Teams without dedicated audio specialists may find the learning curve steep, and the advanced features may be overkill for basic text-to-speech needs where simpler, more cost-effective solutions would suffice. Content creators producing podcasts, audiobooks, and video narration with expressive voice requirements, enterprise developers building conversational AI systems requiring emotional intelligence and context awareness, marketing teams creating audio advertisements with specific brand voice and emphasis requirements, healthcare application developers needing compassionate, clearly articulated patient communication systems.
Great insight. Really helpful context. How to get started. Implementing Gemini 3.1 Flash TTS step by step.
Implementation begins with obtaining API access through Google Cloud Console and configuring authentication credentials. Developers need an active Google Cloud project with billing enabled and the Vertex A IAPI activated. The initial setup requires installing the Google Cloud SDK and configuring service account credentials with appropriate IAM permissions for Vertex AI access. Python developers should install the Google Cloud A Platform Library version 1.40, 0 or higher, while Node.js developers need the at Google Cloud/Vertex AI package version 1, 7.0 or later. The Granular audio tag system uses a structured XML-like syntax embedded within text strings. Basic implementation involves wrapping text segments with audio attribute tags such as important phrase or carefully explained concept. Advanced usage combines multiple attributes within nested tags, allowing for complex expressions like breaking news announcement. The API accepts these tagged strings through the standard text input parameter without requiring additional configuration. Testing and validation require systematic verification of audio output quality across different tag combinations. Developers should create test suites that cover common use cases, including emotional transitions, emphasis patterns, and pace variations. The model provides confidence scores for audio generation quality, helping identify potentially problematic tag combinations. Production deployment considerations include implementing caching strategies for frequently used text patterns and establishing fallback mechanisms for cases where complex tag structures might cause processing delays. Configure Google Cloud Project with Vertex A, IAPI, enabled and appropriate service account permissions, install Google Cloud A Platform Library v1.40, 0 plus for Python or at Google Cloud/Vertex AI v1.70 for Node.js, implement XML-like audio tags within text strings using structured syntax for attributes like emphasis and pace, create comprehensive test suites covering emotional transitions, emphasis patterns, and complex tag combinations, establish caching strategies, and fallback mechanisms for production deployment optimization.
That's a very interesting point. Tell us about competitive context. How Gemini 3.1 Flash TTS changes AI speech landscape.
Gemini 3.1 Flash TTS directly competes with Amazon Poly's Neural TTS and Microsoft Azure speech services, offering superior granular control compared to these established solutions. Amazon Poly provides SSML markup for basic speech modification, but lacks the fine-grained emotional control and multi-attribute tagging system that Gemini 3.1 Flash TTS delivers. Microsoft's Azure Speech Services offers custom neural voice capabilities, but requires separate training processes for different emotional states. While Gemini's model handles multiple expressions within a single trained system, 11 Labs provides high-quality voice cloning with emotional variation, but operates primarily through their proprietary interface rather than offering the programmatic control that enterprise developers require. The Granular audio tag system creates distinct advantages in developer workflow efficiency and application sophistication. Traditional TTS solutions require multiple API calls or pre-processing steps to achieve varied expression, while Gemini 3.1 Flash TTS processes complex audio instructions in single inference passes. This architectural advantage translates to reduced latency, simplified integration code, and lower operational costs for applications requiring frequent speech generation. The model's ability to maintain voice consistency across emotional states addresses a persistent challenge where competing solutions often exhibit voice drift or quality degradation during expressive speech generation. However, Gemini 3.1 Flash TTS faces limitations in voice customization flexibility compared to specialized solutions like Murph AI or Speechify's custom voice training capabilities. The model operates with predefined voice characteristics rather than supporting extensive voice cloning or brand-specific voice development. Additionally, the granular tagging system requires developers to learn a new markup syntax, creating a steeper learning curve compared to simpler TTS solutions that offer basic voice selection through drop-down menus or simple parameter adjustments. Superior granular control compared to Amazon Poly's SSML and Microsoft Azure's separate training requirements, single inference pass processing reduces latency and operational costs versus multi-call TTS workflows, consistent voice quality across emotional states, addresses common voice drift issues in competing solutions, limited voice customization flexibility compared to specialized voice cloning platforms like 11 Labs.
Good analysis. Let's continue. What's next? Future implications for AI speech generation.
Google DeepMind's roadmap indicates expansion of the granular audio tag system to include real-time voice adaptation and contextual speech generation. Upcoming features will likely incorporate dynamic emotional intelligence that adjusts speech patterns based on conversation context and user interaction history. The integration with other Gemini models suggests future capabilities for automatic audio tag generation, where the system analyzes text content and applies appropriate expressive tags without manual specification. Multi-language support expansion is planned for Q2 2025, with initial focus on European and Asian languages that present unique tonal and expressive challenges. The broader AI speech generation ecosystem will likely adopt similar granular control paradigms as developers recognize the workflow advantages of unified expressive TTS systems. Integration partnerships with major development platforms including Zapier, Microsoft Power Platform, and Salesforce are expected to streamline enterprise adoption. The model's architecture suggests future compatibility with real-time voice modification systems, potentially enabling live speech enhancement for video conferencing and streaming applications. Long-term implications point toward convergence between text-to-speech and conversational AI systems, where granular audio control becomes a standard component of multimodal AI interactions. The success of Gemini 3.1 Flash TTS's tagging system may influence industry standards for expressive AI speech, potentially leading to standardized markup languages for audio generation across different platforms. This standardization could accelerate adoption of sophisticated voice interfaces in enterprise applications, educational technology, and accessibility tools. Real-time voice adaptation and automatic audio tag generation based on conversation context planned for 2025 multi-language support expansion targeting European and Asian languages with unique tonal challenges, integration partnerships with major platforms like Zapier and Salesforce to streamline enterprise adoption, industry standardization, potential for expressive AI speech markup languages across competing platforms.
Great analysis. So, what are the key takeaways from all of this?
Gemini 3.1 Flash TTS introduces over 50 granular audio parameters controllable through XML-like tags embedded in text. Single inference pass processing delivers sub 200 milliseconds latency while maintaining voice quality across emotional states. Implementation requires Google Cloud Project setup with Vertex AI API and specific library versions for proper integration. Competitive advantages include superior workflow efficiency compared to multi-call TTS systems and consistent voice quality.
And what market signals should our listeners watch for?
Enterprise TTS market consolidation. Google's granular control system positions Gemini 3.1 Flash TTS as a comprehensive solution that reduces dependency on multiple specialized TTS providers. Enterprise customers seeking unified voice generation platforms will likely evaluate this against maintaining separate contracts for basic TTS, emotional speech, and voice customization services. The single API approach addresses procurement complexity while potentially reducing total cost of ownership for organizations with diverse speech generation requirements across multiple applications and departments. Developer experience differentiation. The structured markup approach signals a shift toward more sophisticated developer interfaces in AI speech generation. Traditional TTS AP is relied on simple parameter passing, while Gemini's tagging system enables complex expressive programming within text content itself. This architectural choice suggests Google is targeting developers who need fine-grained control without complex integration workflows, potentially capturing market share from solutions requiring extensive pre-processing or multiple API orchestration for advanced speech generation. Conversational AI integration acceleration. Gemini 3.1 Flash TTS's real-time expressive capabilities align with growing demand for emotionally intelligent conversational AI systems. The sub 200 milliseconds latency enables natural dialogue flows while granular emotional control supports context-appropriate responses. This positions Google to capture enterprise conversational AI deployments where voice quality and emotional authenticity directly impact customer experience metrics, particularly in customer service, healthcare communication, and educational technology applications.
What should developers and operators do with this information?
Evaluate current TTS usage patterns and identify applications requiring expressive speech generation within 30 days of API access. Implement pilot projects with basic audio tagging for customer-facing applications before expanding to complex multi-attribute scenarios. Establish audio quality testing protocols and fallback mechanisms for production deployments handling high-volume speech generation. Monitor competitive TTS pricing and feature developments to optimize tool selection as granular control becomes industry standard.
Thank you for listening to leadai.dev. Stay tuned for our next daily updates in this rapidly emerging market.